Okay, question number 3. A transport company has detailed records of its deliveries, time, whether they're late or not, is with a mean of 0 and a standard deviation of 4. So if A less than or equal to A is 0.6, find A. So it's going to be the inverse normal left 0.6, 4 and 0. Distribution inverse normal, my left is 0.6. That's going to be 4 and that's going to be 0, okay. 1.01 to the nearest minute, A equals 1 for question part A. Find the probability correct field of a delivery that is no later than 3 minutes after its delivery date given that it arrives on time. Probability that no later, so t is less than 3 given t is bigger than 0. Given that it's been delivery, said it was scheduled after delivery time, okay. So probability of t less than 3 intersect t bigger than 0 over the probability of t bigger than 0, and bigger than 0, less than 3 is in between. So I'm weighing the probability of t going from 0 to 3 over the probability of t bigger than 0. So I'm going to have fraction in the top, I'm going to have the normal going from 0 to 3, 4 and 0, and in the bottom I'm going to drag and drop and going from 0 to infinity. That's going to give me an answer of 0.5467 to 3 decimal places. That gives me an answer of 0.547. Part C, using this model on 19. So what do I know? I know that I don't know the mean. But I do know that between -3 and 2, that is 0.4648. And I also know, given the same mean, going from -4.5 to 0.5, there's some sort of translation happening. So I do know that this area here, that's also 0.4648. This probability here will equal this probability here. And I'm going to use the z-scores to link them together. The z of this number will equal 2 minus the mean on 4, and the z on this number will be -4.5 minus the mean on 4. But this number is going to be a negative value. So to keep these negative z-scores the same, I need to multiply that by negative. So I'm going to have 2 on the mean over 4 should equal -4.5 minus the mean over 4. Solve for the mean. And k is the mean, so I'm going to have fraction 2 minus x divided by 4 equals fraction negative bracket -4.5 minus x divided by 4, solve for x. And that gives me x equaling, or k equaling, -1.25. And I'll just double check that. If it is -1.25, then the normal distribution, interactive distribution continuous, normal CDF, if my lower was -3 and my upper was 2 and the standard deviation is 4 and the mean is -1.25, I should get a probability of 0.4608, which is what I did. And if I went from negative 4.5 through to negative 0.5, and I go OK, I also got the same probability. So that's correct. Okay, so a rival transfer claims that 85% of, rival company claims that 85% will rival on time. So probability on time or earlier, 0.85. Assuming that probability is true, so it's true, so that is the case. Find the probability on a day which the rival company makes 8 deliveries, fewer than half of them arrive on time. So we are binomial, we have 8 deliveries, and 0.85 is arriving on time. So we're wanting the probability that it is, so that's x. X is fewer than half, less than 4, probability that x is less than or equal to 3. And that's going to be interactive distribution discrete CDF. Lower is 0, upper is 3. I've got 8 and it's 0.85. And that is, move the decimal point 3 spots to the left. So 0.00285 to 3 decimal places, 0.003. Assuming that it is true, so we've still got this 8.5. Enter in not arrive on time or earlier. That more than one delivery. So expressed in terms of the probability that one or more deliveries will not arrive on time. So the probability of being late is bigger than or equal to 1. And that's equal to the probability of being early so that's 1 minus the probability of them being late equaling 0, which means they're all early. So 1 minus 0.85 to the power of n, and hence or otherwise, well, at least 0.95, I want 1 minus 0.85 to the power of n, at least 0.95. So if I make them equal to each other, 1 minus 0.85 to the power of x is being bigger than 0.95, and I solve for x. N is bigger than 18.433, n equals 19. Okay, so what have we got here? We've got a number of things. I can either be before 4 or after 4. And I know the probability of being made after 4 is y, therefore that's 1 minus y. And I can be on time or earlier, or I can be late. And I know that's 0.85 from the previous page. And I know that the probability of on time or earlier if you are before 4 is x, if you are after 4 is x, and 1 minus x. So I've got my tree diagram happening. I know that being on time or earlier is 0.75. So being on time or earlier can be from deliveries before 4 or deliveries after 4. So I've got 0.75 can equal 1 minus y times 0.85 plus x times y. And what I'd like to do is I would like to say, find y when x equals, what's the range, 0.3, and find y when x equals 0.7, and that will be my range of y. So on my calculator I've got 0.75 equals bracket 1 minus y 0.85 plus xy, math 3 given, x equals 0.3, solve for y. And that gives me an answer for y of 1/10. And then when x equals 0.7, gives me an answer of y equals 1/2. Therefore, y goes between 1/10 and 1/2. Double checking my work, I missed my 5 here. So I'm going to do that again. That gives me 2/3. And at 0.3, that gives me 2/11. So 2/3 and 2/11. So y goes between 2/11 and 2/3.